Good afternoon, everyone. Welcome to the platform of Inspired Learners. And today I'm going to present the topic of From Newton to Einstein, the evolution of the gravitation theory. My name is Brother Newton Nobert. First of all, I'd like to begin with the words of the famous philosopher Aristotle. Aristotle once said that all men by nature desire to know. All men by nature desire to know. Everyone wants to understand. And according to my thinking, understanding, observation, people love to know three things, three major things. Number one, they want to know God. Number two, they want to know themselves. And number three, they want to know the world or the cosmic. All men desire to know. And most of us will love to know these three things. To know God, to know themselves, and to know the world. But what are the three fields or three disciplines which tells us much about this? According to my observation and my years of studies, I've realized there are only three disciplines that can describe this. These are theology, philosophy, and science. So because every one of us desire to know, everyone of us is born to understand things, to know things. Most of us, we love to know about ourselves, as I said. Everyone wants to know himself, the world, the cosmic, and also God. And these three fields are, to me, the best fields that to understand God, ourselves, and the world. That's theology, philosophy, and science. Now, the third concept that men want to know is the world, the cosmic, the things that are around us, the environment. The best thing to understand this is through theology, philosophy, and science. One of the fundamental questions that many people from years, from ages, from centuries wanted to know is the cosmic, how the world is, how the world is moving, how things are moving in this world, how things came to existence. So this is what the concept of the gravitation theory is, one of the things that help us to understand the third thing, which is the world, cosmic. And 3 years since the time of Aristotle to currently, people are trying to understand about the planets, about our Earth, about the solar system, the galaxy, and all the things that, the questions that were in the minds of most of the philosophers, theologians, and scientists is, how does this world move? How does this world come into existence? And all the things we see, the planets from Jupiter to Mars to Saturn, in our own Earth, the solar system, the sun, how do these things move? We see the sunrise every day, we see the sunrise and the sunset. How does this come? This question have started from years before Christ, since the time of Aristotle to Albert Einstein, to the current scientists that we have right now. And all the things that is the movements of the planets. We want to understand the movement of the planets, how the Earth rotates around the sun, how the moon rotates around the Earth, how this fallen chalk, why this fallen chalk has fallen down. All these concepts men have tried to understand, because we are created to know things. And from the beginning, scientists, philosophers, and theologians have tried to explain this, and this is a development. And today I want to explain the theory of gravitation theory, how it moved, the understanding, how it moved from Newton to Einstein, how Einstein came up with this theory of relativity, divided into two, special relativity and general relativity. Now let us be back on this topic. First of all, we need to understand one question that has influenced years is why the planets rotate the sun. Why is it the sun in the middle, or the planet is in the middle? What makes the black holes? Why is it raining? Why is it sunrise and sunset? So this thing has really influenced a lot of things, a lot of scientists, theologians. But today I want to deal with two great scientists, or sometimes they're also called philosophers, especially Isaac Newton. So today I want to discuss about these two guys. I want to discuss about Isaac Newton. This is a British scientist of the 17th century. And Albert Einstein. This is a German scientist, a Jew born but lived in Germany, which he lived in the 20th century. So we see a man of the 17th century and a man of the 20th century. These two men have tried their best, have influenced how we think about the world. As I said, that everyone has the desire to know the world. So these two men have influenced our thinking, our understanding of the mechanics, our understanding of the cosmic. But we really don't know how we moved from Newton to Einstein. Before coming to that, we need to see what have they contributed to the understanding of the reality, the understanding of the world, the understanding of the cosmos. So we come two of them. We want to discuss Newton, Sir Isaac Newton, and Einstein. One of the things that the fundamental questions that we ask ourselves: why do things happen that they are? Why are the planets rotating? Why are the planets rotating? Why is the Earth rotating? All of us believe at our modern times, this 21st century, that the Earth rotates the Sun. And that's why we celebrate even the New Year, because the completion of 365 days, the moment of the complete rotation of the Earth around the Sun. Why there's low tide and high tide on the ocean? Why is it there's a sunrise and sunset? So these two guys really influenced our understanding of these two concepts of the planets. Newton is famous of one theory. Let me say one theory. His theory is universal gravitational theory. But also he has influenced much in science, especially in the optics, in the telescope, and universal laws of motion. The three Newton's laws of motion. So there are a lot of contributions from Sir Isaac Newton, but we need to deal with these two of them: universal gravitation theory and three Newton's laws of motion. Einstein also is influenced by the theory of relativity. The theory of relativity. Which is divided into two: special relativity and general relativity. But the understanding, everything was based, remember, on the 17th century, we understand the cosmic. We understood the cosmic, how things move through the Newtonians' thinking, Newtonians' discovery. But during the 20th century, this is about 200 years later, we are influenced by the theory of relativity. Now my presentation is: how did we move from Newton to Einstein? I would like to answer two questions here. First of all, the first question is: why planets rotate? What causes the planets rotate? What causes an apple to fall down? What happens? What causes the low tide and the high tides? So Newton tries to call this thing a gravitation. This force, it's a force. Gravitation is a force. This is according to Sir Isaac Newton. Gravitation is a force. But Einstein says it's called gravitation, but gravitation is not a force. Why planets rotate around this? It's gravity, but it's not a force. He says it's something called space-time curvature. He brings a concept called space-time curvature. And many people have heard around the world through different presentations telling us when Newton died when Albert was born, when Einstein was born. Most of the thinking is, many people think that Newton concepts died when Einstein's concepts were born. But this is a false statement, and I don't believe in this at all. What I want to say is that Einstein grew when Newton became old. I'll try to explain this. This is a complex issue, I understand. That Newton died. Many people think Newton died. The discoveries of Newton, the laws of motion, the universal gravitation theory, died when Einstein was born. His theory of relativity, special relativity and gravitation. This is a false thing to me. But my presentation in 30 minutes, I'll try to explain how Einstein grew when Newton was old. Newton became old, hence Einstein grew. So this is a kind of my presentation. My presentation will focus how we moved from believing Sir Isaac Newton to believing Sir Albert Einstein. And what do they stand for? When we build from the other. But before this, we need to start dealing with the first person, which is Sir Isaac Newton. So we'll try to deal first with Newton, then later we'll deal with Einstein, then here we'll try to see how this movement went from here to here. So we begin with Newton. Newton has a very beautiful explanation of things. And I really love, because my name is Newton, because my father loved so much Isaac Newton. So I read much about Newton since I was a kid. So I'll try to explain in a very few moments. And my target is to make it very simple for anyone to understand. Because when anyone talks about Sir Isaac Newton, when anyone thinks about Albert Einstein, complicated, confusing mathematical equation, I wanted to make it in a very simple English that anyone can understand. It won't be an easy text, but I do believe everything will go as planned. First of all, now, we start by saying this. We know that the planets rotate the sun. We all know this, and this is what we believe. Planets, Mercury, Venus, Saturn, Jupiter, Pluto rotate the sun. But what causes this rotation? Why is this rotation? So this was the fundamental question that was asked by Newton. Newton says there is something called a force. Force. The planets rotate around the sun. The planets are in applicable way eclipse because of something called a force. There is a force that makes these planets to move around the sun. And this kind of force, we called it gravitational force, gravity force, gravitational force. This is the same force that explains why an apple falls from a tree. Why does not, when one throws this chalk, why does it not go up? Why is it falling down? So there is something called force. That force, he called it gravity. So according to him, force is that governs the motions. Gravitational force is what governs the motions of the planets, of the stars, etc. The heavenly bodies. This is according to Newton. What governs the stars, the planets, the galaxy is the force. It's a force. What force is it? Gravitational force. So this is the understanding of Newton. And he came up with that, which is very important. He came up explaining this force. What is this force? He came up with a formula called, or a theory called, universal gravitational theory. Universal gravitational theory. What does this mean? Universal gravitation theory is a theory that says forces, every mass attract each other with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. How do you keep this? In formula, Newton says this force equals to, this force that we're going to explain is G m1 m2 over r squared. So this is the short form of the universal gravitation theory by Newton. Well, I'll explain by saying this in a very simple way, that every mass, any two objects together, this chalk, the planets, the Jupiter with the sun, every mass, every object attracts each other by a force which is directly proportional to their masses and inversely proportional to the square distance between them. So he came up with this thing here. But before Newton came up with this thing, he came up with other two very famous theory, which is called the three laws of motion. Three laws of motion. And you know that by first law of motion, it's Isaac Newton, second law, and third law. But I will try to keep it in a very brief way because of my time. The first law, in a short, is called inertia. Inertia is that a body will remain constant without a body will remain constant. An object cannot go. This paper here will never move unless an opposite an opposite is a force which is outside of it presses it. That a body maintains its state unless that an force that is outside of it is initiated to it. Objects keep on doing what they are doing unless forced. Objects remain as they are unless forced by something outside of it. So this is inertia. Inertia. Another force, this is inertia. The second law of laws of motion of Newton is F is equal to ma, which means acceleration. Acceleration of an object is directly proportional to its force and inversely proportional to its mass. This is a very important theory, the second theory. And the last, which is very easy, every action has an equal and opposite reaction. So these are the laws of motion, 3 laws of motion of Newton. Action with opposite reaction. So this is inertia, that an object will remain stable unless a force is applied to it. Inertia is an acceleration of an object is directly proportional to its force, and inversely proportional to its mass. And the third law is action. Every action there is an equal opposite reaction. So before you see, this is complicated. Newton tried to explain the movement of the planets, the movements of a fallen apple, the movement of the galaxy by these 2 theories. But somebody can ask me, how did Newton reach here? How did Newton reach here? If you just listen to Newton right here, you never understand. When we come to understand how Newton reached here, that's when you can move from Newton to Einstein. How did Newton reach there? I'll keep it in a very brief, short way. So the understanding of the cosmic started by being observed by 3 kinds of people. It's scientists, theologians, and philosophers. So the first person who wanted to understand the world, the cosmic, according to the readings, was Aristotle. So we begin. Newton did not come from nowhere. Newton did not come to formulate his laws from nowhere. Newton had a background. So what I'm going to try to explain is the background of Newton. When you understand the background of Newton, that's when you understand Newton well. And when you understand the background of Newton, understanding Newton well, that's when you can move to Einstein. Most people can't understand how we can move from Newton to Einstein because we don't understand the background of Newton. So what's the background of Newton? He began with Aristotle. Newton read Aristotle. Aristotle believed that Earth was the center of everything. The concept called geocentric. So I just go over because of time. Aristotle was the first person to try to understand cosmic according to the researches and books that were written. He said that the center of the cosmic is the Earth. But this was challenged. This was developed by another Egyptian. This was a Greek philosopher, an Egyptian astronomist called Ptolemy. Ptolemy said yes, the Earth is the center, but the Earth, which is the center, where the other planets, including the Sun, rotating around the Earth, they rotate in an eclipse way. And these eclipses are called, there are 2 different eclipses. There is epiclipse and difference. So this guy came with 2 things. He came with something called epicycles and difference. So he says this, yes, Aristotle, F is the center. Tony said, yes, it's true, F is the center, but there are 2 movements. The epiclipse is this way, the things which are near to the sun, the movement of the things which are near to the Earth, because the Earth is the center. And difference are the things, including the sun there, which are moving around the Earth, but at the far. After this somebody came to question this. He said, no, this is a wrong mistake. Why this? If the Earth is the center, why there is sunset and sunrise? How do you explain this? Remember, these were just theory. They are not proved or observed rightly. So a person who challenged this kind of theory, people who really forgot him, is Nicholas Copernicus. Nicholas Copernicus. This Copernicus came around the 15th century. Nicholas Copernicus stated for the first time that he's the first man who came to the understanding that it's not the earth which is the center. The sun is the center of the solar system. The sun is the one which is the center. It's not the earth. So Nicholas Copernicus came with that concept. But this concept was just a theory, an observation and a theory that the sun is the center. So after him, he came the fourth person, who is called Kepler. Johannes Kepler. Now, after Nicholas Copernicus said that the sun is the center and the earth rotates around another planet, rotate around the sun. How does this earth, Jupiter and other planets rotate around the sun? How does this thing rotate? How do they rotate? Then he comes up with three laws of Kepler's. I'll try to, because of time, I'll try the three laws of Kepler's. That first of all, the other things that, because the sun is the center, so everything that rotates around the center, there's the sun. First, it rotates in an eclipse way. It's an elliptical cycle. Second, it revolves with varying speed. And third, radius increases, time increases. When the thing is so close to the sun, the radius is small, so it rotates very fast. But when that thing is very far, something like Saturn, it takes much time. So the time of Earth is fewer compared to the time of Sun, because the Earth is near to the Sun compared to the Saturn, which is farther to the Sun. Then after that came with this, after Kepler, it came number 5, Galileo. Galileo, after Galileo said, this all were just observation. Now Galileo was questioned. Many people did not believe in this concept. Especially some of the books, you see, even the Catholic Church were against this. Because according to the Bible, according to the traditions that are believed by the religion, that the earth was the center. But this is something that was brought, which is by science, which was also somewhat a contradiction to religion and understanding. And the dominant religion was the Catholic Church. So Galileo said, no, this is true. Because Galileo is the first person who discovered the telescope. A kind of distance that he can prove that what Copernicus and Kepler said. So Galileo wrote this down, and it was him who was the father of modern science. To me, the father of modern science is Galileo Galilei. Many people think it's Isaac Newton, but I think it's Galileo Galilei because Newton took from Galileo Galilei. Now, after this case, because of time, that's when Newton comes with the universal theory of gravitation, explaining how the planets, how the stars, how the galaxy are moving in the solar system. Now, how do we move from that to Einstein? We need to note that this theory of Newton, before going to Einstein, so there is Newton here. I'll try to summarize because of time. Then there is Einstein here. I'll try to say here, Newton says space and time. First of all, they're absolute. First thing is absolute. They are fixed. Space and time are distinct and they're separate. This is what the understanding of Newton. Space and time is absolute, fixed, distinct, and separate. This is very important for Sir Isaac Newton. But through this understanding of Newton, there are loopholes. There's a problem. You see, everyone develops from a problem. There is a problem with Isaac Newton. Isaac Newton, his theory cannot explain the movement of Mercury. The planet Mercury around the sun, his theory has a problem with that. There are three things where this theory of Newton has a problem. I'll just note them. First of all is Mercury. how Mercury rotates around the Earth. There's a problem. This theory of Newton does not explain much. Another thing is the explanation of something called black holes. Black holes, it's a very complex situation. Myself, I'm studying about it. It's something is in a one sentence, we're saying the dying of the stars. When a star dies, then when the star dies, it generates a very high gravitational pull where it can even attract the speed of light when it passes through it. The theory of Newton does not explain this. And another thing is dark matter. There's something called dark matter. If you look at the galaxy, there's some dark matter, some pictures of dark matters that you cannot understand very well. And another thing that really lacks from the theory of Newton is he assumes is instantaneous force transmission. And big of all, to me, one of the loopholes, one thing that Isaac Newton really lacks, he says there is this force called gravitational force. But what's the medium of it? How does it function? Okay, there is this force, it does this and this. But what's the medium of this force? How does it operate? How does it operate? Yes, there's a force, but no, how gravity works? These are the questions that Newton was impossible, cannot answer it very well. Even the rotation of the moon around the earth. Remember, which is very complex. Because the sun is in the middle, then the earth rotates around the sun. But also this earth which rotates around the sun, there is a moon. So Newton's theory has a complex to understand this, has some problems to understand this. And Newton knew it even before he died. He knew that there are some loopholes. But unfortunately, he died before understanding this. That's when comes now Sir Albert Einstein. Now listen, this guy wrote his theory, Principia Naturalis of Natural Philosophy, the principles. He wrote a book called, a book very, very famous in Latin, but I'll try to speak it in Mathematical Principles of Natural Philosophy. This is a book which he published in 1687. Mathematical Principles of Natural Philosophy, explaining everything here. But look this, until 1905, that's when Einstein comes. Einstein comes to understand now, to show the movement from Newton to Einstein. How does he come? He comes with something called the theory of relativity. So theory of relativity tries to explain all these things. Now in a very nutshell, because of my time, I'll try to explain very fast this theory of relativity, which is a very complex issue. Okay. First of all, when we talk about, before I'll go back here. So before going to Einstein, he comes with the theory of relativity. Now, this relativity, remember, keywords, theory and law. Newton developed two things: universal gravitational theory and three laws of motion. Those are three laws of motion that became law. But theory of relativity is just a theory. And the universal gravitation theory, it's not a law, it's a theory. You know the difference between a law and a theory. But the three laws of motion are laws. But these are theories. So Einstein came with something called relativity. Theory of relativity. Which is divided into two. Special relativity in 1905 and general relativity in 10 years later, 1915. Trying to understand, trying to explain what Newton missed. Now, in a brief, this special relativity tried to explain how laws of physics that are influenced, the word here is very key word, in absence of gravity. How do you explain the laws of physics in the absence of gravity. And general relativity, how do you explain the laws of gravity under influence of gravity? Under influence of gravity. Under influence of gravity. So this is a major difference between special relativity and general relativity. These laws of in the absence of gravity. General is in the influence of gravity. Relativity. Now, what does these two laws bring? I'll explain I know this is deep stuff. This special relativity brought two things which are very important. It came up with something called space-time curvature. Something called space-time. Space-time. And something called mass, equivalent mass and energy. So this special relativity has tried to bring something called the special relativity, which we know with the famous theory of E is equal to mc square. The special relativity you can explain by E is equal to mc square. That the kinetic energy of an object is mass times the speed of light. So this has brought the concept of speed of light. Newton had no concept of speed of light. In his theory, you have never heard about concept of speed of light. Speed of light. And when you talk about space, people don't understand. According to my understanding, space, when you see the word space, normal thing, when you think about space, is three things. That's why it's called 3D, three-dimensional. It's length, width, and height. When you see something called space. So space-time is outside. Space, when you say space, length, width, and height, time. But now, this was the understanding of Newton. But now, Einstein comes with something called space-time curvature. Space-time curvature means he brings something called 4D. He shows the world in 4D. That's not length, width, and height. But you know that the reality is in length, width, height, and time. Time is inside here. 4D, 4-dimensional. So when you see 4D is length, weight, height, and time. Width, time, length, width, height, and time. So this is a very major development. Curvature, space-time. Now, I round up by saying this. And now this general relativity is when you take now. Here, special relativity, you talk about space and time. But general relativity, that's when you include also not only space, time, but also you add something called gravity. Gravity. As I said, Newton's explanation of gravity is a force. Einstein's explanation of gravity is not a force. Gravity is a curvature, a space-time curvature that contains that makes a web fabric that attracts things. It's not a kind of force to him. So let me conclude. I know that I've done it very roughly, but I want to conclude the movement from how does this movement move. Now, let me just here. Newton, I wrote something here. So for Einstein now, first of all, this space and time is not absolute, it's relative. It's relative. Space and time is relative. It's not absolute, it's not fixed. They are interwoven, they are interconnected. Space and time, according to him, they are distinct. Things that are different, they are separated. But for him, they are connected. They are connected. Because Newton thinks that space then time moves inside the space. It's the things which are separate. But Einstein brings that these two things are interwoven. They are together. They are connected. They are connected, interwoven. That's why he brings the concept of space and time. Now, Let us now conclude by saying this. Newton's law is not dead. Newton's law is not like it's forgotten. It deals with two things. Newton's laws, objects moving at a non-relative speed and for weak gravitational force. Newton's law is still applicable. Newton's law is still applicable, but it's only applicable for weak gravitational fields. But with extreme conditions, such as black holes, Newton's law cannot be applicable. That's why we need Einstein. And that's why we need Einstein. And how do we need Einstein? Now, how do we shift now? Now let's conclude by this movement of shift, and then the movement now. Newton, Einstein. What's the shift? First, these are key 3 points. I'll try to keep. Gravity is not a force, not force between objects. So this is the conclusion. Gravity, according to Newton, gravity was a force. Gravity is not a force, but it is between objects. But curvature of space time itself. So this is what attracts things, heavenly bodies, planets, stars, galaxy. It's not a force. Gravity is not a force that attracts things. No, that was Newton understanding that things are attracted to each other because of a force called gravity. No. According to Einstein, the movement it's not a force. It's a curvature of space and time. These two bodies create a kind of curvature, space-time curvature. This curvature now attracts these things together. It's not a force. I can call it it's a manifestation. I can call it a kind of manifestation. Another concept is space and time. I guess not 3 points, are not fixed. Absolute. Are not fixed absolute, but are relative. To the observer. In motion and position. So this is another movement that is very, very important. This is a very, very important discovery of Einstein that developed from Isaac Newton. That space-time are not fixed, are not absolute, are not distinct, are not separated, but they are relative according to the observer in motion or position. And last, another movement from this is that there is something called the speed of light. Is absolute and constant. It's absolute and constant, and cannot exceed laws. Cannot be exceeded. The discovery of the speed of light by Albert Einstein. So these are the 3 important things of the understanding. But also, in a nutshell, things are keeping on development. We see from the movement of Newton, Aristotle, Ptolemy, Copernicus, Kepler, Galileo, Newton. Now we have in Einstein. But there's something that I need also to read. Is quantum physics. Quantum physics is something new that I think it develops from Einstein. So there is a kind of growth of science. So I'd like to thank everyone for this kind of presentation. And I went very fast in a very brief way, the understanding from Newton to Einstein. One remark that I want to say is that, especially in our environments, I'd like that people should also read much on Einstein, because you see in our secondary educations, in our secondary education, especially in my country, people are so focused on the theory of Newton, but most people are afraid to master Einstein. But Einstein, when you understand Newton, it's very easy for you to go to Einstein. Thank you very much.